All right, so we're going to continue looking at molecular formula problems. We're going to do one of the problems that you had for an assignment, number 17 on page 339. And for that one, we're supposed to find the molecular formula for a compound that contains nitrogen and oxygen. So we start out with 4.9 grams of nitrogen. And we know that we need to get rid of the nitrogen and put it in moles of nitrogen. And nitrogen is 14.0 grams of nitrogen is 1 mole of nitrogen. So the grams cancel. And I'm going to punch that in the calculator. And when punch that in the calculator, we get 4.9 divided by 14. We end up with 0.35 moles of nitrogen. And then we have 11.2 grams of oxygen. We take that times 1 mole of oxygen is 16.0 grams of oxygen. Our grams cancel. So we have 11.2 divided by 16, and we get 0.70 moles of nitrogen. Now remember, to get the molecular formula, the first thing we do is calculate the empirical formula. So we need to divide both of these by the smaller number, which is 0.35. We get 1 for nitrogen. Divide that by 0.35, and we get 1 for nitrogen, that's a no. 2 for oxygen. So right now we have NO2, and that is our empirical formula. So the next thing I need to do is I need to get the empirical mass, empirical formula mass. So nitrogen is 14.0 and oxygen is 16.0, but I have 2 of them. So I've got 46.0 is my empirical formula mass. And now I take the molar mass, which is given to me, and it says the molar mass is 92 grams, and my empirical formula mass, I plug in the bottom, is 46 grams. That means we have, our multiplying factor is 2. So I take this empirical formula of NO2 and then multiply it by 2, and I get N2O4. This is my answer, and that is the molecular formula. So I took the empirical formula, and I had to multiply it by 2, and I did that to get my molecular formula. So you should have got N2O4 for that one, if you work that out right. The next one we work out, in your answer to the other two in your homework, both of them had a multiplying factor of 1, so that didn't change anything. That's not usually the case, but it will be once in a while where the molecular formula and the empirical formula are the same. So we're not going to work out one of those. We're going to do one more. We're going to do number 18 in the book. Okay, let me add another slide here. So number 18 on page 339, it's talking about B-carotene, which is found in carrots. And they give you, they want to figure out the molecular formula. Okay, so they give you the empirical formula. This is just going to be a short and easy one. They give you the empirical formula as C5H7. So they've already figured that out. And now they say, what's the molecular formula? Well, they give you the molecular mass of 536 grams. So you need to divide that by the empirical formula mass. That's what goes in here. So we figure that out with this. So we have 5 times 12.0 for carbon, and we add that to 7 times 1.0 for hydrogen. So we've got 5 times 12, which is 60, plus, and that's just 7. So 60 plus 7 is 67. So we have 536 divided by 67 gives us 8. So we're going to multiply all of this by 8. So instead of C5, it's 5 times 8, which is 40. C40, and instead of H7, we take 7 times 8, and we get 56. So this would be our molecular formula, and we got that by first either calculating our empirical formula or having that given to us. So your assignment then is going to be on the let's see, on the 10-3 practice problems, your assignment is going to be problems. Let's go with problems number 21 and 25. 21 and 25 on 10-3 practice problems will be due tomorrow. If you're having any problems, you can look online, and remember you can look at sample problem 9 on page 338 and 339 for some more help on that. Or you could ask Mr. Bracker what this is titled, and you could watch this again if you would need to. See you guys tomorrow.